A deployment is higher level abstraction that manages replica set and pod. The key features of deployment is rolling updates, meaning let's say we already have an application running with version v1 and it has 10 copies. Now we want to roll out v2. What happens in rolling updates? It not recreate all 10 at once. This causes downtime. Rather, it's going to gradually update all the pods running inside the Kubernetes cluster for this specific deployment. Let's say we want to roll out only 10% of pods at a time. Out of 10, 10% is one pod. Pick that pod, replace with v2. And again, do this for all the pods available in the cluster for this specific deployments. With help of rolling updates, we achieve zero downtime deployments. That feature is part of deployment object. And also easy rollback. If something goes wrong in the deployment, with a simple command, a kubectl rollout undo command, we can easily roll back to its previous stable version. And as usual, we know replica set is therefore to maintain desired number of replicas and pod which runs containers inside it. Let's go ahead and see deployment in action. Let's search for Kubernetes documentation. Copy this YAML document. Let's create a file in Visual Studio Code. Paste it. Let's change this according to our requirement. I want to simply call it Nginx. This is name of the deployment. Labels for the deployment. In this case, labels under deployment is nothing to do with the replica creation and so on. But what is important in match labels? See, replica set going to create 3 replicas by looking for pods with match labels. So app nginx. So this one should match with the labels defined under pod specification. See, we actually do not need pod YAML, replica set YAML. We can delete nginx YAML as well as replica set YAML because we're not going to deploy applications as a pod or replica set directly. We use deployments for deploying applications onto Kubernetes cluster because it comes with a feature called rolling updates and rollback. Let's create deployment using kubectl apply command. The difference between kubectl create and apply is create will newly create the deployment. If I run second time, it is going to fail because a deployment with same name exists. But when it comes to apply, if deployment is not yet created, it creates. If it is already created, it updates. Deployment is created, it internally creates replica set that in turn creates 3 replicas. Let me say kubectl get deployment, it's there. Likewise, kubectl get replica set. We did not create replica set directly. Remember, this is created by deployment. Let's also say kubectl get pods. Of course, there are 3 pods created. Actually, I want to show how rolling updates and rollback works in deployments. In place of Nginx, Let's use Python application. I already have image with two versions, that is with tag v1 and v2. So let's delete Nginx deployment. Let's go to VS Code, update it for Python application. So here, pyapp, update it everywhere. Let's make 10 copies. Let's deploy this. Yeah, almost all the copies are in running state. I made one mistake. Container port is 8000. Let me delete and recreate all the ports. To test this, let's do port forward. This time, I want to port forward deployment. Name of the deployment is pyapp. I want 8080 to be my host port and 8000 is the container port. Yeah, we see the response from a Python application running inside Kubernetes cluster. Let's stop port forward. I want to update the version of Python application to v2. Nothing but we want to roll out the next version v2. Go to deployment YAML, change from v1 to v2. So run a kubectl apply. Now what apply command does, the deployment is already there, that is running v1. So it updates that with v2. Let's see kubectl get pods. So now we have total 13 containers, right? Out of that, you see this one. It is rolling out updates on 5 containers while other containers are still running. I mean, other pods are still running to maintain the high availability and zero downtime. Let me do kubectl get pods. Now, almost all the pods are in running state and see the time difference between a few pods. 40 seconds, 49 seconds, 41 seconds, 39 seconds, right? So this indicates it's not recreating all pods at a time. It is doing a rolling update. Let's do the port forward and check the output. Let's do refresh and see that one. We see the next version where v1 the color was green, v2 the color is red. Let's simulate a failure deployment. Something went wrong in the deployment, that is v2 current version. I want to roll back to its previous version. Let's see how to do that. A kubectl rollout, undo, deployment, name of the deployment. We rolled out v2. I want to undo that. Let's see kubectl get pods, and see there it is rolling back to previous stable version. It's again using rolling updates to maintain zero downtime. Let's do port forward. Let's refresh the page. It successfully rolled back to previous stable version, that is PyApp EKS v1. So we should always use deployments for deploying applications. We should not really use directly pods or replica sets.